So welcome students. So in my previous class we have just got introduced to the stacks. So stack is a data structure as I told you, and when we talk about data structure we actually are referring to the memory. So how the data is stored in the memory and how to manage the data in the memory, how to access the data from the memory. So it's all about that. So in the last class we have learned about stack, and stack is very important data structures, and in coming few days you're going to understand the importance of stack, because there are so many operations that our operating system or the system software performs in which it will make use of the stack. The most important operation, one of the important operation I should say, that where the stack is used, and that is while performing the mathematical operations. So whenever a computer performs any kind of mathematical operations, a stack is used in that. Now what exactly it is and how the system software or the OS is using the stack is what we are going to learn in the upcoming class. Today we are going to implement the entire program. Maybe in the previous class that was the program which was already implemented, but let us just implement the program of a stack from scratch. Okay, so let us just start typing the code. The first thing that we need to do is provide the menu for the user. Now this is an implementation of stack, which means it is a kind of a program which shows how a stack looks like, and that is what you are supposed to program. Okay, so we will be developing a program just to demonstrate how a stack works like, or how it works, and okay, what exactly when we perform the push operation or the pop operation, what exactly happens. So this is what we are going to demonstrate using a program itself. Okay, but the real use of stack is something that is used in, as I told you, the system software will make use of the stack for performing various tasks, and one of the tasks that I told you was the arithmetic operations, some mathematical calculations. It is where it is going to get used, but this is a program where we are going to demonstrate how a stack works. Okay, please understand this. So when we implement a program of stack, it does not mean okay, this is what it is all about. No, we are just demonstrating how a stack works like, and the system software, the OS, is what is making use of the stack, and the demonstration that we are going to show over here is what is exactly how a stack acts. Okay, please understand this. Let us provide a menu first to the user. So I will go for a print statement and a double quotes, and the option one that I will provide is a push operation. So that's the first operation, and then the second operation that I'm going to give is the pop operation. Let me have one more statements, that is number 3, and I can provide the option that is stack pointer. So this will be basically, if you refer the book, if you are referring the book, this will be like the seek option. So it is going to display the element that is on the top of the stack, and then the operation that I can have is the fourth option, and that is display stack. So it is going to display the entire stack. And then the fifth option I'm going to provide is the exit. That's the option. Okay, so since this option should be, it should continuously go on, and once the user will choose an option, after performing that operation again the menu should get displayed. So this I'll put it under a while, and I'll simply say this as true. So this will mean that this is an infinite loop, and then let me just fix up the indentation, and over here I'm going to accept the input, that is okay, one more print statement over here will be that is enter your choice. That's the option, and that in fact I should be using input function, and something like choice is equal to, and let me just convert everything into int. So I'm putting that under the int function. Looks good till here. Then we are going to have the if statement. If choice is equal to 1, let me just have the pass since I don't want to have any code at this point. Then elif choice is equal to 2, then the pass, then elif choice is equal to 3, and elif choice is equal to 4, and then we have the exit option, that is elif, or I can simply say else. So if there is any other number that the user will give, what I'm going to do is I'm going to break the loop. Now this is very important, right? And then over here what we can do is we can have separate methods. So let us just define the methods, I mean the functions. So def, so this will be my pop function, and if you can remember, pop is also a method for I guess for list, or we have this pop method for list, right? So now I'm going to just have this pop method, the pop function. Then okay, this should be first will be the push, and this I can make it as pop. It will not make any difference, just to keep the series in a proper manner I'm doing it. Then we can have def, we can have the stack pointer, that is the seek, which is going to do nothing but just going to display the element at the top of the stack, the element that is the stack pointer is currently pointing. And then I can have one more, that is display stack. Okay, and then I can have the pass. So these are the methods. Let me just give a call to this methods, that is first one was push, and let me pass the list. So list L will be a, you can say, a global variable, okay, or I can name this as stack. Let us name this list as stack itself. So I'm going to pass stack, just the capital letter, fine. And then over here I can have the pop, and over here was the, that was the stack pointer. Let me just have the stack, and then we have display stack. So looks good, and I'm going to pass the same argument, that is the stack. Okay, let us just run this and see if it works or not. So that's the first thing I'm going to do, is any kind of errors we will get rid of it. So this is the menu that gets displayed. So if I say push, so there is 0 or positional argument, is because we have not said uh, we are not given the parameters, that is stack over here. Okay, okay, now let us just run this one more time, and when I say push, okay, it is running now, there is no error as such. Pop, that is stack pointer, and that is again for the display stack, and 5 if I give, it is going to go for the break, and now you can see we are out of the program has terminated. So everything is looking working good till here, and now comes the main part, is the implementation of the functions. So when I say push, so the first thing that I need to do is, you know uh, I need to display the stack pointer, and the element that we have we need to push that element into the stack. So what we need to do over here is, for the push operation, I'm going to take item which we need to push in the stack, and then I'm going to say input, enter a number to push, okay, or enter a number, and then this number also I'm going to pass as argument. Let me come over here and item, and then what I'm going to do is I'm going to say stack dot, and I'm going to say append and the item. So this is going to, push the element in the stack. How I can have the stack pointer? The stack pointer means we will only show the index value where the stack pointer is pointing. How I can show this? Now the first thing, we also need to do some kind of checking over here, that is if stack, okay, if stack or len of stack, or if stack is empty, I can do it this way. If it is, then I will append this, and the stack pointer, so I can have one more global variable, that is equal to 0, or you can say as -1. So -1 means currently the stack pointer is not pointing to anything. So now that we have the stack pointer, we will make it as, if this condition is true, which means this is the first element that will be going into the stack, so I'll make the stack pointer as 0, and else if it is not empty, then what I'm going to have is, I'm going to have my stack pointer, that is stack pointer is equal to len of what? Len of that is the stack, and let us have -1, because that is going to give me the index value. This is a kind of errors. Is assigned to but never used. Now it's okay. So that is my stack pointer. Again, it is showing me the signed but never used. Okay, it's okay. And so that's the first function that we are going to have, is we are going to check for the stack if it is empty. If it is so, okay, let me just run this and terminate, and just for our checking, what we are going to do is we are going to print the stack right over here. Okay, so let it just run. So we're going to write one function, check it, and then move forward, and that's the approach that you need to keep. This is the push, enter a number, and you can see it has successfully worked. It has displayed. Again, if I give 1 and I give 45, and now you can see, okay, that element has not been entered, is because I'm not performing the append operation. Let me just copy this and paste it. Now let us run this program once again, and you can see push operation, that is number 12, and it is showing the stack over here. And then I can give 1 again, 45, and that's the second element. So if I really want to display the stack pointer also, how I'm going to do it, like comma, or let me have one more statement, and we can say stack underscore pointer. Okay, so now this is going to show me the stack pointer. So I'm going to give 1 and 12, and now you can see the stack pointer is pointing at 0. So this is working pretty nicely. I give 145, and now the stack pointer is pointing to, what is the position? The position is 1. That is the index value. Means the stack pointer is now pointing to the number, that is 45. Why 45? Because this is the element which is currently that we had pushed. So stack pointer will always point to the current element that was pushed into the stack. Okay, so this is working pretty nicely. And let us just go fast and implement the pop operation. So over here also I'm going to say if stack is equal to, if it is empty, then you can say that okay, stack is empty, right? If there is nothing to pop, if the stack is already empty, then you can give the message, and then you can just make the stack pointer as what? Stack pointer equal to -1. -1 means now the stack pointer is not pointing to anything. Elif what? If means there is something in the stack, so I can simply I can use else, and what I can do is I can simply pop the element from the stack, and I can simply use stack or n is equal to, and I can use the same method, that is the pop. So what is pop is going to do? Pop is ultimately going to pop the element that is currently pushed in the stack. This method itself works as a pop operation, performs the pop operation for us. This is going to pop the current element that was pushed in the stack, and then you can say print, and you can say the element pop is an n. Let us quickly, and then let us stack pointer. I'm going to use the same statement that is over here. I'm going to adjust my stack pointer. Looks good to me, so let me just print pretty fast stack print, and that is stack pointer. We are going to separately use this stack pointer, separately going to display this, but this is just I'm doing it for the checking purpose. So let me first push some elements in the stack. Okay, you can see now these are the elements in the stack, and you can see the stack pointer. The stack pointer is pointing to the index value 3, that is 0, 1, 2 and 3. Why 3? Because 78 was the latest number that was pushed in the stack. And now if I perform the pop operation, that is number 2, you can see the element popped is 78. Why 78, children? Is because 78 was the last element that was pushed in the stack. And you can see also the stack pointer had adjusted to itself. Now it is pointing to the index value 2, so 0, 1 and 2. So this is how you're going to implement your program. So this is the push operation and this is the pop operation. Now stack pointer is so simple, children. You have to simply use this, copy this and paste. So this is simply going to show you the stack pointer, and then what you can do is you can display the element using, that is stack of, and you can do the checking as well. If it is empty and all that, okay, first to put this check and then you can display this. Okay, otherwise there will be a problem. And then you can simply say stack pointer. So this is going to actually display the current element where the stack pointer is pointing, and please apply this condition: if stack is equal to empty, else all that. Okay, and then simply display stack is where we're going to display the stack. Fine, children. So this is the push operation, pop operation. I'll simply copy this. Rest of the code you have to do it. So I will go to the Word and paste it, and I will give it to you. Okay, and rest of the coding, children, please complete it, and then tomorrow we will understand what is queue. So this is, I'll save this, that is under the folder I have is class 12, and I will name this as stack. Save it and go to file, export PDF file, and the same name I'll keep it. So this is the file, the PDF file, children, getting ready for you. I'll give this thing to you. Please refer to the code, or you can refer to the code that we have in the book as well, but this is one and the same thing. Okay, there might be certain different kind of code that we have, but this makes a lot of sense. Even this will make a lot of sense. Maybe this is the exact code that we have in the book as well. So that's it, children. I'm going to give you that code and please complete the work. Bye for now.